Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Alright, step on inside and we are going to be doing a review of arithmetic, geometric sequences, and series, where it's really just me doing a bunch of problems just over and over. It's relatively mixed. It doesn't hit everything. Now that I realize after building this, it doesn't do things like identify whether something, it doesn't identify whether something's arithmetic or geometric, but sometimes it doesn't state whether or not they are, so you still have to figure it out for yourself, which is fine. But just a good mix of problems. I want to attach the PDFs down below. I'm going to do two of these. They don't necessarily hit one set of problems versus another. It is relatively mixed, as I stated, so one and then the other there. You can check out the PDF for this one and PDF for the next one and decide which problems you want to look at. And I'd love to give you timestamps for these things. Now, when I state all this, I normally have this on delay because these upload overnight. I have other things that I'm working on alongside it, so I have to be reminded. Otherwise I just won't do it. I get a little too busy and other things get in the way. So I'm just going to go ahead and get started, though. We're going to do this one, Module 12 Review A. There will be a B. Like I said, check the other video that will be a follow-up of this one with just other kinds of problems. Okay, this is going to play under some assumptions that we know what's going on in some way. So let's start with this. If this is your first video you've seen with me, and you've done your own bit of review before. For one, we're going to be using subscript notation and not function notation when we talk about an arithmetic sequence. When we talk about an arithmetic sequence. Oh, you know what I'm also very short of on these? I didn't use a lot of recursive rule. Not a lot of recursive rule. Recursive idea is the most important thing that comes in place for the most part. I don't know if there's any recursive rule. We'll see. But the explicit rule that we're using is regarding a sub 1. To find the value of some term n, we take the value of the first term, and we add our common difference n minus 1 times. That's our arithmetic sequence explicit rule or formula. Geometric sequence. I'll just put seek because I need to fit to the other ones here. Geometric sequence, to find the value of some term n, we take the value of the first term and multiply by the common ratio n minus 1 times, like that. Arithmetic series. Whoops, missing a C. Series. We are, what are you talking about? They're all finite. To find the sum here, we divide the number of terms by 2 and multiply that by the first term plus the last term. Again, if you'd like to see the origin of these, kind of the creation, the go-tos, how I made them happen or how we use them, explore the previous videos that I've had very recently on all these things here. It'll help you out. And then lastly, geometric series. There are two different formulas we need. One for a finite geometric series and one for an infinite geometric series. So finite is going to be s sub n equals a sub 1 times 1 minus r to the n over 1 minus r. And then the infinite geometric series is s sub infinity equals a sub 1 over 1 minus r. Sorry again for kind of having it smattering there. These aren't quite as prepped as I had in old videos. In fact, I remember if you go back enough, I don't know what the chapter number was because I didn't title all of my videos for everyone to kind of watch. Maybe I can change the name of it. But there was some chapter review about 5 or 6 years ago. I want to say 6 years ago now, 2020. Yeah, 6 years ago. That I did for an Algebra 2 class where I have the formulas written out on top. We didn't use a lot of first term. We used a lot more term 0, theoretically, but that's okay. But the formulas were on top of everything. But what I specifically remember is, and now I'm kind of embarrassed if I do it here, but we'll see. Maybe I can edit it out later. You should skip ahead of this part. There, I got to prep my voice. I'm going to sing something for you guys. There was a... I hope I don't get copyright strikes for this. There was a show when I was a kid. I don't remember. I don't think I would go like, oh, golly gee, this thing's on. I got to watch it. But there's a show, I think it was called Lamb Chops. I don't remember what the name was. I remember there was a thing called Lamb Chop underwear on TV, and there's a special pair that you can wear. So I think either the character's named Lamb Chop or the show was called Lamb Chop. And at the end of the show, at each episode, they're like these, like, it's kind of Sesame Street. They're like, what do you call them? Like puppets. And like, I'm a lamb, and like, what other animals? I don't remember anything about the show except the end credits. Every time it would end, like, there were people as well that like, interact with the puppets. It's like an educational children's show. And the puppets would sing. I think the lamb would sing to somebody and annoy them. I forget if it was a puppet or a person as the credits were rolling or something. I could find this on YouTube. I should have looked. And the lamb's like, "Hi, I'm a lamb," kind of like, kind of a high SpongeBob kind of voice. And the song was just, it would, this is going to get in your head, so you should skip after this. And more puppets would join in, but it goes like, "This is the song that doesn't end. Yes, it goes on and on, my friend. Some people started singing it not knowing what it was, and they continued singing it forever just because this is the song that..." And then anyway, it keeps going. What did I... Oh yeah, I was like, why am I telling you this? So in my review video that I made for that, I specifically remember that at the very beginning of that, I made a parody version of it that was, instead of "This is the song that doesn't end," I did one that was "This is the sum that doesn't end," and it was about an infinite geometric series. And if I recall, it would have went... Started adding it. Yeah, I think it was... "This is the sum that doesn't end. Yes, it goes on and on, my friend. Some people started adding it, not knowing what it was. It is an infinite geometric series just because this is the sum that doesn't..." And it just keeps going forever, and I forget how I ended it. But I was like, that was pretty good. It kind of works out for this. So, infinite geometric series, it's a sum that doesn't end. It goes on, and all that stuff. Good times, guys. Let's let it roll. Anyway, if that's one thing to help you remember anything, there it is. Okay, here we go. Those are formulas. They will not appear on screen with me. Have them written down, have them accessed, go back to the other videos, memorize them, whatever you want to do. Let's go to work. Number 1. For each of the following sequences, let's find the explicit rule and the indicated term. Now, this is one of those instances where, as I kind of stated before, I didn't tell you whether these were arithmetic or geometric. That being said, there are no problems that are asking you whether things are arithmetic or geometric, but you got to know what these things are for these to work. I never said these were arithmetic or geometric, and these might be one or the other, or hopefully not neither, because then you're going to have to work on how do I make that formula, and we haven't really practiced that for like a quadratic or Fibonacci or something. What we have to do in each of these is determine whether there's a common ratio or a common difference. If there's a common difference, it's arithmetic. If it's a common ratio, it's geometric. Some are more obvious than others. Maybe all of these are very obvious for you. I know they kind of are for me. And like I said, I'm not going to be teaching as much as doing. Right here, I think we can all tell that we are subtracting 3 each time. If you're subtracting 3, that means there's a common difference. And if there's a common difference, that means there's an arithmetic sequence. And if it's an arithmetic sequence, that means we'll use the arithmetic sequence formula. We have a first term value of 8. We have a common difference of -3. The value of any term n explicitly can be found by starting from the first term 8, subtracting 3, n minus 1 times. And that is the answer, given that it is arithmetic. To find a sub 24, we substitute 24 in for n in this equation. It's going to be 8 minus 3 times 24 minus 1, or 23. 3 times 23 is 69, so it's 8 minus 69, which is -61. I hope I didn't mess anything up there. So that should be right. So -61. There's that first one. Now B, this 2 is staying the same on top, while this thing is growing by a factor of 3 each time. I think it's safe to say we're multiplying by 1 on top, multiplying by 3 on bottom there. 3. So that must mean we have a common ratio here, and that's a common ratio of 1/3, with a value of the first term being 2/3. So in this instance here, we're looking at a geometric sequence, right? Geometric sequence here with a common ratio. So we would use the geometric sequence, formula. We start from the first term of 2/3, and we multiply by 1/3 n minus 1 times, like that. And that would be your explicit rule, which we're going to be using for right here. And, if you don't mind, I'm going to probably give you the fraction answer. As nothing's going to be able to reduce here, right? It's going to be 2 over something. So a sub 9, I'm going to take 2/3 times 1/3 to the 9 minus 1 power. That's the 8th power. So what I really need to do is I need to figure out, it's 1 to the 8th over 3 to the 8th, right? So I need to figure out 3 to the 8th power. Whoops, didn't type an 8 there. 3 to the 8th power is 6,561. So this is 2/3 times 1 over 6,561. And like I said, nothing's going to reduce here. So whatever 3 times 6,561 is going to help me out here. This is 2, let me just put it up here. 2 over 19 683. I mean, that's exact, right? That's the value of the ninth term. Now, if you approximate that, if I said round to the nearest tenth, see that's 0.0001016111, and that's just those decimals. This should keep going, right? This should repeat. So that's, rounded to the nearest two decimal places is 0. So that's not good enough here. I really like that answer for it. There's no fraction reduction to be had. That's not impossible to be asked of any person embarking these. All right, part C. Looks like we have a common denominator of 5, with the exception of this one. That's 1 over 1. We could write that as 5 over 5, couldn't we now? Yep, if these were all common denominator of 5 and we're adding 2 on top, that's a common difference of 2/5. What's 9/5 minus 7/5, etc.? All those, or 1 minus 3/5. You're getting 2/5 there. Common difference of 2/5. A sub 1 being 3/5. This is an arithmetic sequence with a common difference there. Starting from the first term, let's add, and it is adding, let's add that 2/5 n minus 1 times. To find the value of the 15th term, we are going to go ahead and substitute 15 in for n. So let's do it. That's going to give us 3/5 plus 2/5 times 15 minus 1 is 14. So 3/5 plus 28/5, which is 31/5. There's no problem with having a, now this could, we could write this as a decimal, but everything else is written as a fraction, even improperly. As long as this isn't an integer answer, which it's not, it's 6.2 exactly. There's no problem with writing it like this either, getting the 15th term like that. All right, so that's the first three there, finding them. So we did have to actually identify what the sequences were there to even move forward. Okay, find the sum of each on this one here. Now, we are expected to possibly, these are series. It's probably best that we use their formulas, especially in the confined space and how many terms we have to use. But in order to do this properly, understanding in this explicit rule here that this very much takes on our arithmetic sequence set, that this is an arithmetic series. So in arithmetic series, we'll be doing S sub n equals, once again, that's n over 2 times a sub 1 plus a sub n. So what we need is the number of terms. That is 13. Point blank, from 1 to 13, there are 13 terms. We need the value of the first term and the value of the last term, a sub n or a sub 13. We need those three things in order to substitute these and figure it out. Now, if this is an exact explicit rule form, that means our first term is 6. If you know exactly that it is in that form. Otherwise, substitute 1 for n, you'll figure it out. A sub 13, 13 being the last term, we got to substitute now 13 for n. That'll be 6 minus 4 times 13 minus 1, which is 12. So 6 minus 48, which is negative 42. So we have the first term, last term, and number of terms here to then figure out S sub 13. The sum of the first 13 terms here. 6, by the way, common difference is negative 4. So this would be 6 plus 2, because 6 minus 4 is 2. 6 plus 2 plus negative 2 plus negative 6, etc. We expect a negative answer. This will be 13 over 2 times 6 plus negative 42, or 6 minus 42, which is 13 halves times negative 36. Could I do this? Let's see, negative 18 times 13. I don't know that. I'm not going to spend a long time on that. 234. Negative 234. So that should be our sum of our first 13 terms in that finite arithmetic series. All right, this one's a geometric series, plain as day. It's got that value of first term times common ratio to the n minus 1 power kind of appearance to it. And that does make this thing the value of the first term right here, your a sub 1 being 2, one of the things we need. Common ratio being negative 4, another thing that we need. And number of terms being 6, from 1 to 6, the third thing that we need. We don't need the value of the last term in a finite or infinite geometric series. We just need these 3 bits here. So to find the sum of the first 6 terms here, you take the value of the first term times 1 minus r to the nth power over 1 minus r. Now, you can go straight into the calculator, work this thing out. Generally, I would. I'm just going to clean some things up to start with, make sure you understand what we're looking at. This is 2 times 1. Now, I got to subtract this here. Negative 4 to the 6th power happens before subtracting the negative 4. Whereas on bottom, 1 minus negative 4 is 1 plus 4. That's 5, right? But on top, I got to do negative 4 to the 6th power first. And that'll actually give me a positive answer. So that's 4,096. I'm doing 1 minus 4,096. Keeping in mind, this minus is here. And negative 4 to the 6th is a positive number here. So I'm subtracting a positive, right? So subtracting a positive is subtraction, though. So, let's work some things out some more. That's negative 4,095. So 2 times negative 4,095 divided by 5 gives me negative 1,638. Negative 1,638. Right there. So I expected a negative answer. Well, actually, not necessarily true. This sequence, let's play with this sequence. This would have been 2 times negative 4 is negative 8. So 2 minus 8 plus 32 minus 128 plus, I think that's 512. 512 minus 2,048. So what's happening here is our result here is positive, and then you subtract it. The result's negative, right? 2 minus 8 is negative 6. It's negative, and then it goes back positive, and then it goes back negative, and it goes back positive, and goes back negative. As the signs alternate, the even termination would have given us a negative result, which this did, and an odd termination would have given us a positive result. And that's why it's important to kind of distinguish between what that thing would have been, a minus or a plus there, among anything else. So that's your final answer on that one there, and kind of short on room, but let's move forward to this one here. From 1 to 12, that's 12 terms. The first term, don't just say it's 6, it's not. Substitute 1 for n. 6 times 1 is 6, minus 3 is 3. And the 12th term, 6 times 12 is 72, minus 3 is 69. So, sorry, this is an arithmetic sequence because it has a, it has a common difference. The common difference is 6. You're multiplying your common difference by your number of terms, which means you're adding that common difference that many times. So recognizing the arithmetic sequence form lets you know what kind of formula you're using there, right? Geometric uses the exponents. Arithmetic uses the linear basis there. All right, so the value of 12 terms added together here is going to be n over 2 times a sub 1 plus a sub 12 by the first term divided by the last term. So that's 6. 12 over 2 is 6 times 72. 420, 432. I'm just gonna say it out loud. Never mind. I'm not gonna say it out loud. All right. That's all of number 2, finding those sums. Number 3. For the geometric sequence, they're telling you it's 1. For the geometric sequence shown here, find the common ratio and a sub 8. All right, they're telling you it's a geometric sequence here. That means we don't need to test over and over to see what we're doing to go from one to the next. We just need to find in one instance what we're multiplying by to go from one to the next. So I'll be honest, if you were trying to come up with it point blank in doing it, figuring out 2 times what to give us 1 and 3 times what to give us 2, I mean, those are fractions that doesn't work out the way that you'd want it to compared to the others. It'd be easier to say 1 times what gives me 3 and 2 times what gives me 8, or 3 times what gives me 9, 8 times what gives me 32, in which case that would be 3/4, right? 1 times 3 is 3, 2 times 8 is 4. But if you were ever so compelled and you weren't, or they were harder to do and you weren't sure, you wanted to work on this one, you'd say, hey, what is 1/2 divided by 2/3, which is 1/2 times 3/2, which is 3/4. So we do get a common ratio of 3/4 no matter what you do there. You can get it. All right, a sub 8. In order to get this here, we do need to kind of figure out the explicit rule for this. And we needed the common ratio. So the explicit rule would be taking the first term of 2/3, multiplying by 3/4 n minus 1 times. So a sub 8 is going to be 2/3 times 3/4, 8 minus 1 times, so 7 times here. And I'll let you know what, this is some fraction reduction to be had. You don't reduce 2/4 right here to make a 1/2 and 3/3. You got to raise to the 7th power first, but there will be some fraction reduction to be had. Good news is, we know what we can reduce them by. We'll be able to divide by 3 for sure, and some factor of 2 or 4 to reduce this thing. So let's go to work on it. Now, there's another way to do this. Multiply by 3/4 again and again and again. 4 more times, right? We could also do it recursively. I'd say that's a little out of window range, but also not really. Yes and no. You know what? I'll do that as well. I'll figure out what that is that way. And then that way, our fraction will already be reduced in that form. Okay. So 3/4 to the 7th power, 3 to the 7th, is 2187. So 2/3 times 2187 over. And I'm doing this first before the full-on calculation. I'm not attempting to round this thing. 1/6. I keep running into these numbers. 16384. In my previous videos, I feel like I'm getting these. 2 over 16384 can both divide by 2, right? So you get 1 over, I don't know, 8192. And then we can divide this here by 3, right? So that's over 1. And 2187 divided by 3, 729? Yeah, 729. So this ends up being 729 over 8192. Whoops. 8192. And yeah, that's as reduced as you can get, right? Because our factors of what we saw here, there's no reason why anything else should reduce further. Now, if we did this way, times 3/4, etc., you do 9 times 3 times 3 times 3 times 3, and 32 times 4 times 4 times 4 times 4. Looks like you'll probably be landing on 729 over 8,192. Rounded to the nearest 2 decimal places, it's 0.0, well, it's 0.088989258. So 0.09. I mean, that's not as, I like the exact. All right, number 4. Find the sum of the even numbers from 1 to 78 inclusive. All right, this is one of those ones that's like, oh, we haven't really heard a problem like this before, the way that it's presented. Okay, so the even numbers from 1 to 78 inclusive. First of all, 1's not an even number, so we don't start from 1. We actually start from 2. Now, the word inclusive means that anything on the ends are included. If they weren't, we'd say exclusive. So if I said 1 to 78 exclusive, that means 78 wouldn't count. Neither would 1, but 1's not an even number anyway. But the last term in our list here is, indeed 78. Okay. Now, to find the sum of the even numbers here, we have to kind of figure out how many even numbers there are from 2 to 78. Now, it's very likely we can state that there are 39 of them, right? Because that's how that thing would pair off from 2 to 78. What would be our best way to go about recognizing that it would be that, though? You could find out by saying that if the nth term is 78, we know our common, oh, by the way, common difference is 2. If we know that our last term is 78 and our common difference is 2, we can use our explicit rule like this, and we could find out what our common difference is, not our common difference, our number of terms is that way. So we could say 78 equals first term plus common difference n minus 1 times, like that. Subtract 2. I'm just going to go ahead and divide by 2 right now. Divide both sides by 2. We get 38 equals n minus 1. And add 1, you get n equals 39. So your number of terms is 39. 39 pairs from 2 to 78. Now, we still have to add them all up, but I needed the number of terms to make this thing work. So I'm gonna go ahead and erase that. I'm just giving you a means to figuring that out, because that's one of the things you're going to be asked to do here and there. Find the number of terms given the information that you have. Determine the common difference by 2 plus 4, etc. So what we're doing here, really, is we are, I don't know if we have to write summation notation later, so I'm just giving it to you straight. No, I'm not going to do that. Let's go to our sum. The value of the first 39 terms here. So we're doing 39 over 2 times 2 plus 78. Okay? Which is 39 over 2 times 80. 80 over 2 is 40. So 39 times 40. Well, 40 times 40 is 1,600, so minus a 40 is 1,560. So if I didn't mess anything up there, that should be 1,560. Okay. All right, number 5, find 4 arithmetic means between 2 and 8. That means that in some arithmetic sequence here, we have 2, and then there are 4 terms in between. Well, there are 4 terms empty, uncertain of, that when we add some common difference over and over, eventually we get to 8. So my favorite way of doing it is recognizing how many times we have to add a common difference to get to 8. plus the common difference here, once, twice, 3 times, 4 times, and a 5th time, right? There's that 5th time to go. So this would be 2 plus, that would be 2 plus 5d equals 8. Subtract 2 from both sides, you get 5d equals 6. Divide, you get d equals 6/5. Now, I'm going to write it as 1.2 because it's exact, and that can get us to where we need to easily enough. So, to find the means, we have to go ahead and add 1.2 each time from one number to the next. 2 plus 1.2 is 3.2, plus 1.2 is 4.4, plus 1.2 is 5.6, plus 1.2 is 6.8, plus 1.2 indeed gives us 8. And those are the 4 arithmetic means between 2 and 8. Okay, insert 2 geometric means between 6 and 162. This means that from 6, there's a blankety, blankety, and 162 here. And because it's geometric means, we are multiplying by some common ratio once, twice, 3 times to get to 162. That means this is 6 times r cubed. That equals 162. If we divide both sides by 6, we're going to get r cubed equals... let me figure it out. 162 minus 6. 27. And the cube root of 27 is exactly 3. So r is 3. So we're multiplying by 3 over and over each time. Well, 6 times 3 is 18. 18 times 3 is 54. And 54 times 3 is 162. This isn't guess and check. It's algebra. It's understanding what it is that you're doing with it. We're getting exact answers. All right, number 7. The 6th term of a geometric sequence is that. Oh my goodness, did I make you do this problem? Is negative 7168 over 729. So a sub 6 is this, mamma jamma. The first term is 7/3. Find the common ratio. Well, the same kind of thing can apply as we were just looking at before. It's the steps before the geometric mean stuff, the geometric means. You can just list it out, instead of actually finding out what the numbers are in between, you just find out what you're multiplying by to get each time there. So this is the first term. Second term, third term, fourth term, fifth term, sixth. Wait, I should write the sixth term. Well, it's a fraction. Negative 7168 over 729. Let's make sure. 1, 2, 3, 4, 5, 6. Yes. So how many times are we multiplying by r? Once, twice, 3 times, 4 times, 5 times. 7/3, oopsies, 7/3 times r to the 5th power equals negative 7168 over 729. Now, if I divide both sides by 7/3, that's also multiplying both sides by 3/7 there, 3/7. Really hoping for some fraction reduction. I know 3 over 729 is 1 over, I think, 243. But 7168 over 7, I'm uncertain of. 7168 divided by 7. All right, that's 1024. So this becomes, let's see, so those are gone. So this becomes, let's write this. This is 1 over 243, and that's a 1 there, and that's 1024, negative 1024. So now we have r to the 5th. R to the 5th power equals negative 1024 over 243. And we have to take the 5th root of this thing right here. That's what we're trying to solve for. 5th root of this, 5th root of this. You can take a 5th root of a negative number. You'll get a negative result from that. So what we're really hoping for is this is the 5th root of something. 5th root of 1000. You can raise it to the 1/5 power if you don't know where 5th root is in your calculator. But I think it's 4. I'm just going to do that. 1024 to the 1/5 power. Yeah, it's 4. Negative 4 over, and I think that's 3. 243 to the 1/5 power is 3. So negative 4/3. That's your common ratio. Now, I'm not actually finding out all the numbers in between. They just said find out what the common ratio is. There are other ways to do it. What you could do is you could say, let's see, how do I put it? You know our geometric sequence formula. A sub 1 times r to the n minus 1 power. You could say, all right, well, if a sub 1, excuse me, if a sub 1 is literally a sub 1 times r to the 1 minus 1 power, which could be cleaned up as 7/3. Sorry, I'm just going to keep working on this. No, hold on a second. Did I write something wrong? A sub 1. There was probably, you know what? There's probably an easier way to do this one. I could have. Oh, you know why I didn't do it this way? I don't know why. The other way was we should have said a sub 6. If a sub 6, excuse me, a sub 6 negative 7168. I think I just got bogged on the idea these are all geometric means, which they are. But I think doing it this way probably would have been more proper. You know, it's the same math. So a sub 1 times, is it negative? That was positive, that's negative. So positive times r to the 6 minus 1 power, right there. We could have solved for r by these means. Now it's the same, it's the same setup, right? 7/3 times r to the 5th, right there, equals negative 7168 over 729. So that's kind of the same setup. I just wanted to give you the approach that I like to look at in geometric means with you, saying how many times we're multiplying by it, all that jazz. Okay, so let's keep moving forward here. I think that was that first page. Here's one more page, and then I'll have another video for you for some more review. All right, what is S sub n for the arithmetic series for which a sub 1 equals 3, d equals 0.5, and a sub n equals 7.5. Now it is straight up. Those are the things that we need for the answer here. So, no, I take it back. We do need the number of terms. So we need the number of terms for this thing here. We don't need d. We got to use d to get that. So a sub n being 7.5, let me write out the formula again for substitution purposes. We got to find number of terms here to start with. How many terms are there from 3 to 7.5? So it's kind of like what I was just doing before, right? So 7.5 equals a sub 1 is 3 plus common difference is 0.5 times n minus 1. Let's subtract 3. Divide both sides by 0.5. That's multiplying by 2. So we get n minus 1 equals 9. Add 1 both sides, we get n equals 10. So we have our number of terms, and then we need our last term in our sequence and our first term in our sequence for our formula here. So S sub 10 is n over 2 times a sub 1 plus a sub, essentially a sub 10, the 10th term in the sequence. So it's 5 times 10.5, which is 52.5. I'm going to double check that. 5 times 10.5. 52.5. Right there. That is the sum of basically 3 plus 3.5 plus 4 plus 4.5 plus 5 plus 5.5 plus 6 plus 6.5 plus 7 plus 7.5. Those 10 terms added together give us that. All right, in a geometric series, if r is 2 and the sum of this finite series is 1533, let's find the value of the first term. All right, we know that it's 9 terms big as well, so what we need to find out is just the value of the first term. I think we have everything we need in our formula, though, given that it's S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. We do have every other bit of information there. So what I'm going to do is substitute all those. S sub 9 being 1533, a sub 1 being what we're looking for, times 1 minus r is 2, and this is 2 to the 9th power over 1 minus 2. Now, let's put this part to bed to begin with in denominator. 1 minus 2 is negative 1. I'm just going to just multiply both sides by negative 1. I don't want the negative on this a side if I don't need it. So this is going to be a negative over here, okay? So we got negative 1533 equals, this is a sub 1 times, I guess there'll be a negative here anyway, 1 minus 2 to the 9th. That's 1 minus 512, I believe. So negative 1533 is negative 511 times a sub 1. If you divide both sides by negative 511, I think that's just 3. Yeah, a sub 1 is 3. So the value of the first term there is 3 in our sum. So we're working our formula, and you're just using algebra to solve the rest of it. Nothing unheard of there. Just make sure you know what formula to use, and make sure you know your algebra. You should be squared away. All right, number 10. For each infinite geometric series, state the common ratio. Then state whether or not the given series converges or diverges. If the series converges, find its sum. So what we know here is we have a sub 1 over 1 minus r. This only applies if you have a common ratio that's less than 1, either between negative 1 and positive 1, like that. So if our common ratio is more than 1 or negative 1, on either side, then it diverges. There is no sum. So it will converge If it's less than 1, it'll diverge. If it's more than 1, and if it converges, we'll use this formula. So here we go. This one here looks like we're dividing by 2. That means we're multiplying by 1/2, right? Times 1/2. Common ratio is not 2, it's 1/2. If it's 1/2, then the series converges. If it converges, we can find its sum. We're going to go ahead and do that. I think if you've seen any problems with me before, I think this answer is supposed to be 8. So it's supposed to be double the first term, but let's check it out. The value S sub infinity is a sub 1 is 4 over, yes, 1 minus 1/2, which is 4 over 1/2, which is 4 times 2, which is 8. So the sum of that sequence there will be adding up closer and closer to 8 as we move forward. All right, part B, we are multiplying by 4 each time here. Your common ratio is 4. That means this series diverges. Because it diverges, there is no sum. We leave it. We don't do anything to it. No sum. Part C, multiplying by 4 again. Doesn't matter that you have negatives involved. Honestly, negative positive has nothing to do, even for common ratio, negative or positive has nothing to do with whether the series converges or diverges. It's whether its absolute value is greater than 1 or less than 1. This one is an absolute value that's greater than 1. It also diverges, so we leave it. I'm surprised I gave too many problems like that. All right, part D, -3 plus 1 minus 1/3 plus 1/9 minus. So with this alternating bit right here, if you're unsure, divide 1 by the one before it. 1 over -3, that's -1/3. Nothing else to say on that. But it's an alternating sign, right? So it's a common ratio that's negative. The point is it's a fraction that's less than 1 as an absolute value. It's between -1 and 1. This thing converges. It converges. So we must find its sum. Now it's going to alternate in between as it adds and subtracts, etc. Looks like it's going to be somewhere between -2 and -3 as a final answer here. But let's check it out. Let's even get a fraction answer. So the infinite sum series, we start at -3 over 1 minus, what is it, -1/3. So that's negative. I went ahead here. That's -3 over 1 plus 1/3. 1 is 3 over 3. So 3/3 plus 1/3 is 4/3. I keep doing that. So -3 over 4/3 is -3 times 3/4. Did I say that right? Yeah, I guess so. I was thinking 4/3 would pop up. So that's -9/4. -9/4. That's -2 1/4. That thing converges toward -2 1/4. And as I expected, it was supposed to be somewhere between -2 and -3. So if you put -2.25, it's still exact. That's fine. Just be careful on ones that aren't exact. Number 11. Given the geometric sequence here, what term has a value of 1/8? So with this one, establish what pick the two smallest numbers if you're uncertain. 16 over 32, that's 1/2 or 0.5, depending on what kind of answer we get. I'll use the 1/2. I'll use the 1/2 here. So what we have is a sequence, not a series. We're trying to figure out which one has that value of 1/8. You take half over and over. Maybe you could just keep multiplying by 1/2 to figure it out. But maybe I could give you a harder problem if you don't. So we have the explicit rule. A sub n is the value of the first term times the common ratio, n minus 1 times. Now we got to figure out which n has 1/8 as its value. So 1/8 equals 128 times 1/2 to the n minus 1 power. Now, I'll let you know this here. We are going to play a little bit of a guess and check game ultimately with this, and I'll show you what I mean with it. Because unless you've learned logarithms, we are not going to be able to just get exact answers for us. I mean, we will through guess and check, but to solve for a variable algebraically in an exponent, you would use what are called logarithms for this eventually. But what do we have to do first? We're going to have to divide both sides by 128, which of course means multiply by 1 over 128. Oopsies. So 8 times 128 is 1024. So this gives us 1 over 1024 equals 1/2 to the n minus 1 power. As 1 to any power will give us 1, we're really trying to figure out 2 to what power gives us 1024. You know what I mean? So 2 to the n minus 1. 2 to what power gives us 1024? That's what this thing will become. N minus 1 will be whatever the exponent is. That's where logarithms would take place. And if your classes use logarithms in that sort of way, you would be doing n minus 1 equals log of 1024 over log of 2. I'm not going to play that way with my own particular class in general, but if you compute that, you can actually figure out what it is. But 2 to the 10th is 1024. I know that. You can work it out, multiply 2 a certain number of times. So that would be n minus 1 equals 10. Therefore, n equals 11. That means the 11th term is that. Let's see if that works out the way it was supposed to. I'm just going to keep dividing by 2 in my calculator, and I'll see which one gives me 0.125. That's what 1/8 is, 0.0125. So I'm at the 4th term here at 16. The 5th, oh, no, you know what? We don't need a calculator for that. We can forget the 0.125. Let's try that by hand. The 5th term is 8, the 6th term is 4, the 7th term is 2, the 8th term is 1, the 9th term is 1/2, the 10th term is 1/4, the 11th term is 1/8. So that works out as well. Mr. Robinson, that was so much easier to do recursively than that. Okay, well, if you understand what you're working on with it, I can't object unless I say solve algebraically. But algebraically, once again, if problems are really difficult to do, you would work that out. All right, 4 more questions. Wait, was there another? No. Number 12, find the 11th term of this, 2 root 3, 6, 6 root 3, 18. They don't state whether this is geometric, arithmetic, or what have you, but it most certainly wouldn't be arithmetic. Otherwise, you'd see everything have a root 3, or you would see like terms not combined. So given root 3s are coming and going, that means there's some sort of root 3 or multiplying to get there. Is it just root 3? Is there more? Well, let's figure it out. Let's try 6 root 3 divided by 6. If there's a common ratio, then we use 6 root 3 divided by 6, and that gives us root 3 exactly. I mean, look, we know it's geometric here. And look, if you don't, let's try some of that. What is 2 root 3 times root 3? Does that give us 6? Well, root 3 times root 3 is 3, and 2 times 3 is 6. Yes, it does. So our common ratio is root 3 here. That's something to establish. And as we're doing that, finding the 11th term means let's write out its explicit rule. So a sub n is the value of the first term times the common ratio, n minus 1 times. That gives us 11th term, a sub 11 equals 2 root 3 times root 3 to the 11 minus 1 power, to the 10th power. So the square root of 3 to the 10th power should be the same as 3 to the 5th. It should be 243. Let's check it out. Square root of 3 raised to the 10th power, 243. So a sub 11 is 2 root 3 times 243. 2 times 243 is 486. So this becomes 486 root 3 right there. Trying to make sure I did my math on 486 right. I think so. All right, number 13. Which term of the arithmetic sequence here, -2, -6, etc., is -126? So this time it's told it's arithmetic. You could also tell that it is via the common difference of subtracting 4 each time. Let's work this thing out given its rule. Its rule is the value of that term, of term n, starting from the first term of -2. We're subtracting 4n minus 1 times. We got to find out which term, n, is -126. So I substitute -126 over here. I'm going to go ahead and add 2 to both sides to start with here. Remember, you don't do -2 minus 4. I add 2 to both sides, I get -124. It's -4 times n minus 1. I divide both sides by -4. You can distribute, but I'm going to divide. Divide both sides by -4, and I get 31. And add 1 to both sides to get n equals 32. So the 32nd term is that value. So again, just solving algebraically, working your thing in a different form. You have the output, you have the value of the term, and you're trying to find out which term gives you that. All right, last 2 here, and then another sheet down the line. Find a sub 1 for the arithmetic series where s sub 36 equals -2412 and d equals -4. So if I said sequence, I apologize. I mean series. Okay, so we have to work out the, let's see, find a sub 1 where the series is. So understanding that this is our formula here, right? We need to find the a sub 1. we have the series bit, we have the number of terms, right? N is 36. N is 36. And we have our S sub n as S sub 36 here as negative 2,412. So with n being 36, we get to do 36 over 2. Oh, you know what? I have more that I have to do here. We need to find a sub 1. You know what? We need to find a sub n. We need to find a sub 36. So in order to do this thing here, a sub 36, let's use our explicit rule. A sub n equals value of the first term. Oh, we don't have value of the first term. Plus common difference minus 4. Hold on. A sub 36 is value a sub 31 minus 4 times n 36. N minus 1. Hold on. To get a sub 36 here. Hold on. Let me think about this. We might have to do this instead. A sub n. You know what? We'll just work it out like this. We can't fully guarantee what it is without knowing the first term, but we can use this formula here for it. So a sub 36 is going to be whatever a sub 1 is. A sub 36 is this many times further out. Basically, what you're doing when you do a sub 1, or I mean, I'll explain it when you see it, but when you do a sub 1 plus a sub n, it's there's something to it. So 35. So that's this number here. So a sub 36 is a sub 1 minus, I mean, I do these problems. I don't know the problems beforehand, so I'm processing with you. So a sub 1 minus 140. So whatever a sub 1 is, a sub n is 140 less than it, right? If we don't know what 1 is, then we can't really use the other there. So the idea here is I'm going to substitute right here a sub 1 minus 140 to then figure out that answer. So we have everything involved. Now we just need to actually just divulge that information, right? Kind of figure it out within. It's a difficult problem, I guess, you know, when you work it out. So negative 2,412 equals 36 over 2 is 18. Inside here I have 2 times a sub 1 minus 140. Okay. This time I'm just going to go, well, can we divide it by 18? 2, 4, 1, 2. We should be able to. Divide by 18. So negative 134 equals 2 times a sub 1 minus 140. I'm going to add 140, and I think I get 6. 2 times a sub 1. Divide by 2, I get a sub 1 equals 3. So the value of the first term is 3. All right, there it is. The value of the sixth term, I guess, you know, do 3 minus 140. It's negative 137. And that probably works out in our favor. So that's the value of the first term given all of that. All right. All right, and lastly, number 15, the number 173 is what term in the arithmetic series here? So we literally kind of just did a problem like this before. Common difference here, we're adding 5. Common difference is 5. We need to figure out n. We don't know n. We know the first term is is negative 7. And the value of term n that we know is 173. So if a sub n equals a sub 1 plus d times n minus 1, we shall add 7, divide by 5, I think that's 36, and add 1, n is 37. So the 37th term. All right, there's a nice backwards work there. All right, guys, so that ought to do it for this one here. Now, there's going to be another review video that I do ultimately make that it has more kinds of problems. I don't know what kind of diversity it has on top of this. Probably more of the same, just some variety. So I'll do one for my students one day, one for my students the other day. But that ought to do it for this one. This is Mr. Robinson. Thank you so much for watching, and take care. I will see you in the next one.